By now, some of you have thought about using an if else if chain and thought, okay, what happens if I have a selection where I have a lot of alternatives to select between? So, not something as condensed, but potentially condensed as grades for a grade point average A, B, C, D. But what happens if I have letters of the alphabet A, B, C, D, dot, 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 X, Y, Z? And that's where 4.14 with the switch statement comes in handy. Now, this starts on page 204. And what a switch statement is a 100% complete stand-in, for the most part, complete stand-in of a complex if-else-if chain. So what we want to do is take all of the nesting that we would see with an if-else-if chain. So if, else, if, else, if, else, if, else, if, else, if, else at the end, what ends up happening is we keep getting indentation, 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 and it chews up a lot of screen real estate. The more of that kind of indentation you have, the more difficult it is for the next developer in the chain to be able to go through and pick up for the first time your piece of code and see where everything is. And frankly, the more difficult it is for you the next time around you come through as the next developer in the chain to be able to see exactly what is going on with your own code. So what we have is the idea of a switch statement, and the switch allows us to condense the if-else chaining so that we can see everything in kind of a nice linear order. Before we get there, I should mention that there are limitations on what we can use in the switch statement. We must switch on integers or characters for this particular this particular expression here in C++. So if you are planning to use strings with a switch statement, which I know many of you are going to want to do, that is not going to work. There is no logical reason for you to use floating point or double numbers here for a switch to work. Boolean doesn't make sense because that's really an if, right? Potentially an if else. And there's really no cause for that to be here. So when we use cases, we are going to use characters and we are going to use integers in order to be able to do that. So here we'll start on page, and I'll just highlight this here. We absolutely positively walk through this block of code in the code sample section. I just want to highlight a little bit of the syntax here, and then you can meet back with the end of chapter code samples to see how exactly this works when we're running it in Replit. In this particular example, what we are using the case to do is something very analogous to what we were using our if else chaining to do before. We have the idea of our grades, right? So we can say A, B, C, or D. You'll notice A, B, C, and D are integers, and they're not integers, they are characters here. So as characters, we can use them in the switch. So here in the code, you can see on line 12 that we have our keyword for switch. It is switch, all lowercase. And then inside of the parentheses, we have the condition on which it is we are going to switch. In this case, it is choice. So you'll see that choice is a character. So that means it is a valid data type for us to be able to use here in the switch statement. And then inside of our switch statement, you'll notice that we have a statement block there. So that is our opening and closing curly braces. Inside of that, we have our secondary keyword, which is case. So that is here on the left-hand side. Case followed by what it is that we are looking for. So we could say case A, B, C, and D. And remember, because these are characters, those A, B, C, and D, are wrapped in single quotes. We also have a semicolon there. So, or a colon. I keep doing that. I apologize. You'll also notice that we have a colon there, not a semicolon. The semicolon, I was about to say, goes at the end of your statement, not the middle. If you put a semicolon there, very probably you'll run into a logical error because that's going to end the statement, and then you would have your C out there. What essentially will happen is nothing will be associated, potentially nothing will be associated with that, that particular case in your switch statement. So each one of these in this particular example represents only one particular line of code. You can have multiple lines of code here represented for each one of these cases in your switch statement simply by wrapping them in, you guessed it, a statement block, a secondary nested opening and closing curly brace. The one additional portion here I want to mention now, and we will see it when you get to the code sample at the end of the chapter here, is the idea of falling through. You'll notice on lines 15, 17, and 19, we have another new keyword there, and that is break. What ends up happening in a switch statement is as follows. Each one of those cases are evaluated. So A is the first one that is evaluated. Now, let's just, in our minds, remove those break statements on 15, 17, and 19. What ends up happening is if you don't have those break statements there, the code will do what is called falling through. It's going to keep executing on each one of those subsequent cases, even in the case that they are incorrect. So if I remove lines 15, 17, and 19, and I enter for my choice character an uppercase A, line 14 is evaluated first, and that character does in fact match case A. So the cout statement there is going to say you entered A, and then it's going to fall through. The next executable statement is line number 16, you entered B. The next executable statement is line 18, you entered C. So that's not what we would expect, and certainly that's not what the user on the other side of the screen would expect when they are running your code. So those break statements enable the that line of execution, line number 14. So when my choice character is an uppercase A and it does evaluate as true on line number 14 that the case does match uppercase A, we will get an output of you entered A. The next line of code is a break. So what's going to happen is C++ sees that statement block, so the statement block that begins on 13 and ends on 21, and it will return to the next line of code in normal flow outside of that statement block. So it's line number 22, and then we get return 0, and we're out of our program. So it's something to be aware of here when using the switch statement is the idea of falling through. You should have those break statements there, unless, of course, you want your code to actually fall through. So we do have an example of that here in our code. Here we go. And this is program 4-26. This is on page 208. And you can see we can use that idea of falling through to our advantage. So what happens if the user enters a lowercase a, or what happens if we as the developer want to be able to account for the uppercase A and the lowercase a? Well, what we could do is we could put those two cases next to each other. And you can see that here. It's program, again, 4-26 on page 208. And what we can do is put that A choice for the lowercase and then the A choice for uppercase. So what happens in the case that the choice character is a lowercase a? So you can see that here on line number 19, we have an empty statement. What that's going to do is force that to fall through, and it's going to go to line number 20, line number 20 rather, and it's going to say 30 cents per pound. So the example is a little different here. I do wish they'd done the same thing, but you can see that lowercase a falls through to uppercase A. What happens if we were going to put in an uppercase B for our choice character? Well, line number 19 evaluates as false, it skipped. Line number 20 evaluates as false, it skipped. Line number 21 is associated with 19, it is skipped. Line number 22 evaluates as false because I have uppercase B. Line number 23 finally evaluates as true. So then the rest of that line is executed, and we see 20 cents per pound would be our output. Then the next line of code, so normal flow, top to bottom, left to right, in that order exclusively, gets us to that break statement. That break statement gets us out of this program block. So this program block ends on line number 29, so that's where normal flow would go to, is down here on line number 29, and then we get our return 0 statement. So what would happen if we would have, for example, for leading example, for foreshadowing for homework example? What would happen if we have vowels and consonants? We could do this really pretty simply. We could have A, E, I, O, and U as our vowels. And in the cases of A, E, I, O, we could have simply empty statements. In the case of Y, we could have an output. This is a vowel. Then we would have our break statement. And then all we would have to do is have an else, a catch-all there. It's our default statement. And you can see that here still on program 4-26. The default case in our if-else chains, we had the else as our default case. Here, we simply call it default. It's all other characters. If we're just checking for vowels and consonants, and we're sure that the user is going to enter correctly a vowel and a consonant, we could just have a default case to say the character you entered is a consonant, and then remember the break after that statement. So we can use the idea of falling through to our advantage, and certainly you can see we can use a switch statement to our advantage, because look at how much more it condenses the code. It lines everything up really nicely for us in a nice linear fashion, and it makes it so that you and the next developer in the chain, which oftentimes is going to be you, can really in quick and logical ways see what that otherwise potentially, calamitously dense if else chain would have looked like. Switch statements really truly are, and you guys are going to ignore them until I tell you to, but switch statements really are a very useful tool for the C++ developer.